In this section we want to talk about adding and subtracting radical expressions. What we're going to find is that it pretty much boils down to combining like terms in a sense. So let's do a little review of what it means to combine like terms. If we want to simplify 2x plus 3x, or in other words, if we want to combine them since they are like terms, well, how do we do that? We just add the coefficients. 2 plus 3 makes 5. So 2x plus 3x makes 5x. Okay? What makes these like terms is the fact that they both have an x. They have the same variable with the same exponent. Okay? So, let's look at a few instances of terms that are not like terms. If instead of 2x plus 3x, we say 2 plus 3x. We can't combine those. This is as simple as it gets because of the fact that this is 3 times x, and order of operations tells us we have to do this multiplication before we can do this addition. So we can't do 2 plus 3 and get 5x for this. Okay? If we think about putting in a number, let's say x is 4, then 2 plus 3x is going to be 2 plus 3 times 4, which is 2 plus 12, which is 14. Whereas 5x, if we did 2 plus 3 to get 5, so we have 5x, that's going to be 5 times 4, which is 20. They are clearly not equal to each other. Okay? Think about it. This doesn't have an x attached to it, and this does. They can't be combined. Okay? They're two different kinds of creatures. Another example where we cannot combine because they're not like terms is if we have 2y plus 3x. Well, now they both have a variable again, but this variable is not the same as this variable. So we can't put them together if they have different variables. Even though they both have variables, we can't say this is 5xy or something. That doesn't make any sense. Another thing we cannot do is combine those. 2x squared plus 3x. Well, this has an x just like this one, but this x is being squared. This x is not being squared. Okay? So this would be like 3 apples. This would be like 2 bushels of apples. You're not going to add those together and get 5 bushels of apples or 5 apples. It doesn't make sense to put them together. They're very different. So to have like terms, they have to have the same variable with the same exponent. Now let's see what happens when we replace our variables with radical expressions. Well, if we have 2 square roots of 5 plus 3 square roots of 5, it's no different than if we had 2x plus 3x. We can just add the coefficients, 2 and 3. Okay? And so we get 5 square roots of 5. Because these are the same kind of thing. They're both square root of 5 terms. What we cannot do is just like what we can't do with variables. If we had 2 plus 3 square roots of 5, where one of them has a radical and one of them does not, we cannot put them together. This is the best we can do. We have to have 2 terms. Can't put them together to make one term. They're not the same thing. Not the same kind of thing. Okay, well, let's throw another radical on there. Can we put these together? They both have radicals. Well, we still can't, because this is kind of like if we had 2y plus 3x. Yes, they both have radicals, but they're different radicals. Square root of 6 and the square root of 5 aren't the same kinds of radicals, so we cannot combine those either. Okay. Finally, what if we have 2 cube roots of 5 plus 3 square roots of 5? This is kind of like 2x squared plus 3x. Okay? In that case, the variable was the same. In this case, the radicand is the same. But the index is different. That's like the exponent on the variable being different. We cannot combine 2 radical expressions if the indices are different. They have to be exactly the same. Same radicand, same index. See? Same radicand, 5, same index, 2, because it's the square root. That means we can combine them. Again, it's only like radicals that may be combined. That means they have to have the same radicand and they have to have the same index. Let's see an example. 4 square roots of 2 plus 5 square roots of 3 minus 3 square roots of 2 plus the square root of 3. What's like and what's not like? Well, square root of 2's match up here. They're both square roots, so they have the same index. The radicand is 2 for both. So those match up. Okay? So, combining the coefficients, 4 minus 3, that gives us 1. So, the square root of 2. 5 square roots of 3 and the square root of 3, again, are like radicals. Square roots, they have the same index. Radicand on both is 3. So, we can combine those. 5, what's the coefficient here? Just like with a variable. There is 1 of these square roots of 3, so it's 1 square root of 3. So 5 plus 1 makes 6 square roots of 3. So we've got square root of 2, and we've also got 6 square roots of 3. These are being added together, so it's the square root of 2 plus 6 square roots of 3. Let's see another example like that. 11 minus 4 cube roots of 6 minus 3 plus the square root of 6. What are the like radicals? Well, these don't even have any radicals, so they are like. 11 minus 3 makes 8. What about these? Here we have minus 4 cube roots of 6. Here we have plus the square root of 6. Are they like? Well, 6 is the radicand for both. However, this is a cube root, so it has index 3. This is a square root, so it has index 2. They do not have the same index. They are not like radicals. So we can't combine them, nor can we put either one of them together with this 8. So we have to leave them separate. 8 minus 4 cube roots of 6 plus the square root of 6. Notice once again we did not do 11 minus 4 because these two represent unlike radicals. Nor did we do negative 3 plus 1. These also represent unlike radicals. Also, in addition to that, don't make this mistake. Negative 3 plus the square root of 6 is not equal to the square root of 3. You can't just take negative 3 plus 6, get 3, and say, oh, it must be the square root of 3. You can't put these together in any way. You cannot combine the radicands. In fact, you can't even do that if they are both like radicals. You have to only combine the coefficients. To illustrate that, let's look at the square root of 4 plus the square root of 9. We know that the square root of 4 is 2, the square root of 9 is 3. So this should be 5. Okay? What we cannot do is add 4 plus 9. That gives us the square root of 13, which is definitely not 5, because 5 is the square root of 25. Okay? So, you cannot take two radical expressions and add them by adding their radicands. This is not acceptable. You can only combine like radicals. These are not like radicals because their radicands are different and they must be the same to combine them. Okay? This is sometimes confused with the product rule. Remember, the product rule says that we can multiply radical expressions by multiplying the radicands under a single radical. Well, just like always, you got to keep straight the difference between what you can do when you multiply and what you can do when you add. When you multiply, we can combine the radicands. When we add, we have to have like radicals.